What's up guys, and welcome to this video. This is on the 2016 final exam. We're going to go over question 1, which has to do with multiple choice. Okay, so let's get straight into the questions. Okay, so which set of physical quantities consists of scalar quantities, only scalar quantities, only being the key word. Okay, so as soon as we see a vector, we can disregard it. Velocity is a vector. Displacement, okay, so these are acceleration and velocity are all vectors. Time is a scalar, distance is a scalar, and speed is a scalar. So I would say the option for 1.1 is C, but let's just check the last one. Acceleration is a vector. Okay, so 1.1 is C. Okay, so question 1.2, a car is traveling west at 12 meters per second when the driver notices a stop sign. Okay, so let's draw a car, and it is traveling in that way, in the westward direction. Okay, the driver applies the brakes and the car accelerates. So the car stops at the stop sign, which is the best description of the velocity and acceleration while it is slowing down. Okay, so let's say this is the stop sign. Okay, so if that was the stop sign, the car is always moving in the westward direction, right? So we know that. So our velocities are definitely in the westward direction. So the acceleration, if we were accelerating towards the west, then we would be increasing in speed, okay? But we are decreasing in speed, or we're slowing down. Therefore, the acceleration must be in the eastward direction. So we're looking for west and east. So our option is B. So question 1.2, the answer is B. Okay. Next question, question 1.3. Okay, so a small airplane starting from rest can achieve a high speed or high enough speed to take off from a runway that is 400 meters long. Another heavily loaded aeroplane, also starting from rest, has the same acceleration, but needs to achieve twice the speed to take off. What is the minimum length of runway? So the question is asking for the minimum length of runway needed for the heavy plane. Okay, so let's start off with the light plane. Okay, so this is clearly a constant acceleration problem, right? I hope you guys were able to pick that up. So for the light plane, we need UVATs. Okay, so the initial velocity is 0. The final velocity, we don't know what it is, so let's just give it a value of v. The acceleration, again, we don't know what it is. The time is an unknown again, and the displacement is known. The displacement is 400 meters, right? Okay, now let's look at the heavy plane. Okay, so for the heavy plane, UVATS. Okay, so the initial again is 0. The velocity this time, if we read the question, it says it needs to achieve twice the speed. Okay, so to achieve twice the speed as a small one, we need to go at 2v. Okay, the question also said that it has the same acceleration. So the acceleration is a. T again is an unknown, and s is what we're looking for. Okay, so s is the value we're looking for. Okay, so let's start off. We don't have time, so the only equation we can really use is the equation v squared equals u squared plus 2as. Okay, so we know that v is equal to 0, so that goes to 0. So we're left with v squared over 2a is equal to s. Okay, and we know that s is also equal to 400 meters. Okay, so I'm going to leave that aside now and go ahead with this heavy plane, and I'm going to do the same. I'm going to say v squared equals u squared. I'm going to say this is s1 plus 2as. Okay, s1 and s2. Okay, again, u is equal to 0 because it starts from rest. So we're left with v this time is equal to 2v, right? So 2v squared divided by 2a is equal to s2. Okay, if we multiply that out, we get that 2v over, or 2v squared over a is equal to s2. Okay, so now we need to compare s1 and s2. Okay, and I can see this immediately. If we say s1 times 4 Okay, then we're left with let's see, 4v squared over 2a. Okay, and this simplifies to 2v squared over a, which is equal to 2s1. Okay, so no, sorry, it's equal to s2. Okay, so I hope you guys are able to see that. Okay, these two are equal. So by multiplying s1 by 4, we can get the value of s2. So therefore, s2 equals 4s1, which is equal to 4 times 400, which is equal to 1,600 meters. Okay, so now the question is 1,600 meters an option? And yes, it is option D. So 1.3 we can say is option D. Okay. Okay, the next question. A block is suspended by a light vertical string from the ceiling. Which force forms a Newton's third pair with the weight of the block? Okay, so remember, if we just look, weight of the block. Okay, so weight. Okay, so what is weight? Weight is the force that the Earth exerts on the book or on the block. Something. What is it? On the block. Yeah. Okay. So we want the action-reaction pair. Okay. So to do that, we just need to basically invert the two forces or switch them around. So instead, the action-reaction pair would be an upwards force, which is the force, this was meant to be force, okay, so force that the block exerts on the Earth. Okay, so we're looking for something that sounds similar to that. So it is the gravitational force exerted by the book on the Earth. Okay, so that fits the profile, so we'll go with A for now. The force that the ceiling exerts on the book, no. The weight of the book has no Newton's third, no, that's not true. There's always a Newton's third law pair. The force of tension in the string acting on the block, no, that is not true. That is an external force. Okay, so we're left with option A. So question 1.4, the answer is A. Okay, I just want to also point out something, that for most of these questions, I don't even look at the options available to me. I try to answer the question in a way that I can, and then see if my answer links up to a given answer. Okay, this is a good technique to try and prevent you from getting tricked into assuming certain answers being correct or getting tricked. Okay. Yeah. Okay. So question 1.5 says the diagram below shows two blocks sliding on a frictionless surface. The smaller block is traveling faster. It catches up and collides with the bigger block. Okay, frictionless surface. Okay, cool stuff. The two blocks stick together. What is the speed of the two blocks after the collision? Okay, so this is a conservation of momentum question. Okay, so the momentum before the collision, so I'm going to say the momentum initial is equal to the change in momentum final. Okay, let's rather say, okay, so the momentum total before is equal to the momentum total after the collision. Okay, so the momentum before is going to be the mass of the small block times the velocity of the small block plus, okay, I'm going to take the rightward direction as being positive, plus the mass of the big block times the velocity of the big block, okay, which is equal to the momentum after. Okay, remember, after the collision they stick together, so essentially they have a mass of 4m. Okay, so it's going to be 4m times the velocity final. Okay, so if we add this up, we are left with 5mvi is equal to 4mvf. The m's cancel, and we're left with 5 over 4vi is equal to velocity final. So is that an option? Yes, it is, option D. So question 1.5 is going to be option D. Okay, so a roller coaster starts from rest and rolls down a frictionless track, reaching a speed of v at the bottom of the track. Okay, so if we want the roller coaster to have a speed of 2v at the bottom of the track, what must we do to the track? Okay, so this is a conservation of mechanical energy problem. Okay, so what must we do to the track? Okay, so if we look at the first scenario, let's say this is the roller coaster. We've got the roller coaster up here, and here's the bottom. Okay, at the top, I'm going to say that's position 1. At the bottom, I'm going to say this is position 2, and I'm going to say our point of reference, or the datum point, is going to be at the bottom. Okay, so I'm going to say the mechanical energy at the top must be equal to the mechanical energy at the bottom. Okay, so at the top I have a half mv squared for my kinetic energy plus mgh. Okay, but at the top it is at rest, right? So that velocity term goes to 0, is equal to a half mv squared plus mgh. Okay, but at the bottom, because I've taken the bottom as my reference point, this h goes to 0 and that term goes to 0. Okay, so a couple things cancel, the m's cancel, so we're left with, if we solve for v, so I'm specifically solving for v because I want to relate things to speed. Okay, so v for scenario 1 is going to be equal to the square root of 2gh. Okay, so the question is, how do I get v to be increased by a factor of 2? Okay, so to do that, remember this 2 is a constant already, g is a constant already, so I have to mess with my height. So to get twice the height, so for v nu, to get twice the height, to get 2 square root of 2gh, sorry, to get twice the velocity, I need to multiply the height by 4. Okay, so this is what we're after. Okay, so this is what we're after to get 2v, because this is equal to 2v. But to get that, I need to multiply the height by 4. So that I'm left with, or maybe I should actually do it like this, 2g times 4h. Okay, then the square root of 4 becomes this 2 over here. So I have to multiply the height by 4. Okay, so to multiply the height by 4. Okay, so is that an option? Make the track 4 times higher, option C. So question 1.6 is option C. Okay. Okay, which one of the planets depicted will have the greater free fall acceleration on the surface of the planet? Okay, so this is just, we're using equations here, so we have g small t, or the gravitational acceleration, is equal to the gravitational constant times the mass of the planet over the radius of the planet squared, right? So now I'm just going to go through each option, A, B, C, and D, and just plug in values and see which one gives me the biggest one. Okay, so for the first one, okay, also g is going to be the same for all of them, right? So g is a constant, so I'm actually just going to ignore the g completely. So the relationship is between mass and the radius. So for the first one, our g is going to be equal to m over r squared. For the second one, we're going to have 2m over r squared. Okay, so far the second one is bigger. For the third one, for 2m, I'm going to have 2m over 2r all squared. So then I'm left with m over 2r squared. So again, B is the winner between B and C. And for the last one, I have 3m over 2r everything squared once again. So we're left with 3m over 4r squared. Okay, and that's 0.75, whereas 0.75 m r squared, whereas this is 2. So once again, B wins. So the option is option B. So question 1.7 is option B. Okay, so two charges of equal magnitude are placed as shown in the diagram below. Okay, so all of them have the same magnitude. In which direction does the resultant electric field at the dot have the largest magnitude? Okay, so where is the magnitude the largest? Okay, so basically I am just going to act as if this is a kind of force field and say which direction will this point charge move. Okay, so let's say this was a positive point charge. So let's say all of them were positive point charges. Then the negative will attract it and the positive will repel it, right? So that's quite a large force. Okay, in this case, if we have a positive, they're both going to repel, right? So essentially nothing's going to happen there. Okay, so far A is winning. If we have a relationship where we've got a positive here, so this is going to pull it, but then A is going to push it, but because it's further away, remember we're looking at electric fields, so the force equals K Q1 Q2 over R squared, so the further you are, the smaller the force. Okay, so essentially it's going to get attracted but very little, so the resultant attraction is small, whereas the resultant attraction here is quite large. Over here there's nothing, and in this case we have, if we have a positive, it's attracted and attracted, but it's attracted less from the further one, so it's a small attraction. Okay, so clearly this bigger one wins, so option A is the winner, so question 1.8 is A. Okay, I hope that one made sense. Okay, so 5 and 10 ohm resistors are connected in parallel as shown in the diagram below. We want the relationship between I1 and I2 which can be expressed as the following. Okay, so first of all, I'm going to start off by saying the current going into this, I'm going to name current I. Okay, then I'm going to express I2 and I1 separately. Okay, so I2, remember when we're splitting, the smaller resistor, okay, so that's actually I1. So I1 has the smaller resistor, so it's going to get the larger charge. Okay, so we're going to have the total resistance is equal to 15 ohms, so that's going to be in my denominator for both of them. Okay, but what are we dividing by? So the smaller one, the smaller resistor gets the larger resistance, if that makes sense, the larger current. So I know that I1 should get a larger current, so I'm going to put 10 here, and I know that I2 gets the smaller current, which will be a 5. Okay, and that's all the ratio of I. Okay, so I2 gets 5/15 of I, and I1 gets 10/15 of I. Okay, then what I'm going to do is I'm going to take I2 divided by I1. Okay, so when I divide this, I'm left with 5. Okay, these 15s cancel, so I'm left with 5 over 10, and these i's will cancel. So now we want it in terms of I2, so I2 is equal to, making I2 the subject of the formula, we're left with 5 over 10 I1. Is that an option? 5 over 10 I1, option B, so 1.9 is option B. Okay, so that one was a bit difficult for me to explain. I hope you guys understood what I'm saying. I hope, yeah. So basically when we have resistors in parallel, the smaller resistor will always get the greater current. Okay, so yeah. Okay, then question 1.10, a metal ring lies on a table. When the south pole of a magnet moves towards, so we have south and north, so south moves towards the ring, a current is induced. When viewed from above, okay, so this is my table, by the way, and this is my metal ring. When viewed from above, the direction of the induced current. So what direction is my current flowing in? Okay, so if I move my magnetic field inwards, then a north is made here. A north magnetic field is created using Lenz's law, I think it is. Oh no, sorry, a south is created there because it wants to do the opposite. So if I'm putting my south pole into the ring, then a south pole is generated in the ring, which would create a clockwise rotation. Okay, so therefore the top of the ring becomes, or the top side becomes south and the bottom becomes north, and so I'm left with a clockwise because there is increasing flux. Okay, so clockwise because the flux is increasing. So that's an option A. Okay, so I hope that also makes sense. Yeah, this is mostly a theory question. So if that, just go look up on that theory. Okay, cool stuff, guys. So we've done that and we've got our 20 marks for all the multiple choice questions. Let's see, 1.10 is option A. Okay, cool stuff, guys. Thanks for watching and I hope you found this useful.